Okay everyone, this is section 7.5. In this section our goal here is to be able to rewrite logarithmic expressions. We have three main properties of logarithms. The first is the product property. We said that if log base b of m times n, we could just split it apart with the same base b of the logarithm, but we're going to throw in m times n and break it apart with the plus sign, or addition. Okay, but when m is divided by n, like in the quotient property, we could just split them apart using subtraction. And last but not least, the power property is if we have log base b of m to some kind of power, what we could do is take that power or exponent and tack it out front of the logarithm and leave the base alone on the inside of the logarithm. Okay, so those first three. Like in example 1, we're going to use the following information to evaluate the logarithms. So they give us that log base 4 of 3 is about 0.792, and the log base 4 of 7 is about 1.404. So, with this given information, we can use the quotient rule to split apart this fraction. Okay, so I'm going to use the same logarithm of the top, subtracting it from the logarithm of base 4 from the bottom, which was 7. And I split this apart using that quotient property. And they give us what log base 4 3 is. That's 0.792. And the log base 4 7 was 1.404. So when I subtract those, I get about negative 0.612. In example 2, we're going to use the same information to do log base 4 21. Well, we only know stuff about 7 and 3, and we're going to make a 21. Well, I know that 3 times 7 is 21. Okay, and we could break apart that logarithm by addition from that product property. And we already know the approximations for each of those again. So when I add these two together, I'm getting 2.196 approximately. In example 3, same given information, but I still only know about 3 and 7, and I got to make a 49 using 3 or 7 or both. Okay. Well, I know 7 times itself is 49. So again, I could just break this apart using addition from the product property. And substitute in what I do know, what they gave us about log base 4 of 7. And we get that 2.808 approximately. In example 4, now we're going to expand or make it longer or bigger, this logarithmic expression. So I know log base 6 of y. Right off the bat, I got a fraction that I can divide into or separate into using the quotient property. So we can do that first. So the same log base of 5x cubed minus log base 6 of y. And now I'm going to break apart my first logarithm here. So I could break that apart using addition, because those are being multiplied together. So log base 6 of 5 plus, to break this apart, log base 6 of x cubed. And then minus what we didn't use, log base 6 of y. But one more thing, I can expand. I got this power of 3. I could use the power property to move it out front. So lastly, I got log base 6 of 5 plus, when I move it out front, 3 log base 6 of x minus log base 6 of y. So here's the expanded version of what we just started with. In example 5, which of the following is equivalent to this expanded logarithm? So if we first start out by noticing, do we have any powers that were out front? Well, just off the get-go, I had this 3, which meant originally it was a power. So let's condense that a little bit. So log of 9 plus log 2 to the third power minus log 3. And from left to right, kind of like PEMDAS stuff, we can condense this plus sign because originally that meant they were being multiplied together. But I do know 2 to the third power is 8, so it's kind of like saying log of 9 plus log of 8 minus log of 3. And again, with that plus sign, that means that they were multiplied together. So 9 times 8, which is 72, minus log 3. And lastly, this minus sign we could deal with. That meant originally they were being divided by each other using the same logarithm. So log 72 divided by 3. But log 72 divided by 3, 72 divided by 3 is 24. And we can stop right there because that is our letter choice D. And lastly, we're going to talk about is the change of base formula. So we can change it out of some kind of base and put it into another one using this formula. It could work with any kind of base of any kind of number. Okay, so the most common we use is just the regular base of 10 log, or we can also use the natural logarithm, which is base e, but we just normally use the log because it's the more common, hence common logarithm of log. And finally, in example 6, we're going to evaluate log base 3 of 8. So log base 3 of 8 equals, well, according to the change of base formula, the log of the base goes on top of the fraction. And our base was 3. And in the bottom, I had that backwards, sorry. Log of whatever you're taking the logarithm of, which was the a part, goes on top. So that was the 8. And the log of the base that you're working in, which was 3, goes in the bottom. And if we put this in the calculator, clear out what we got, alpha y equals it to make a fraction. I got the regular logarithm of 8 over the logarithm of 3, and it's approximately 1.893 if we round it off. So approximately 1.893.